Hey guys, so today we're gonna make an ultrasonic distance sensor and we're gonna read the distance on an LCD. Without further ado, let's get into it.
For the wiring, I'm gonna use this model. Um, yeah, I designed this model on Tinkercad. So basically, it's the same model I used for my LCD. So the LCD is pretty much the same. If you missed that, you can always check my previous video, or you could just find it somewhere. It's pretty wild to use online. So I'm pretty sure you can find how to wire an LCD, or you can just base yourself on this model and wire your LCD. Or if you want to, you could always not use an LCD and just read the distance from the serial monitor in the Arduino IDE. So that's pretty much it for the LCD. But coming for the ultrasonic for the ultrasonic sensor. So pretty much for the ultrasonic sensor, we have the VCC, the trigger, the echo, and the ground. So the VCC is the 5 volts coming out of the Arduino, and the ground is the common ground in the Arduino. The trigger, we're gonna connect the trigger to the digital pin 9, and we're gonna connect the echo to the digital pin 10. So for wiring an ultrasonic sensor is pretty simple. It's 4 pins, one 5 volt, the other one is ground. And then there's a trigger pin and the echo pin, which are both digital pins. And now we're gonna go over the code that we're gonna be using for this project. So this is the code that we're gonna be using for this project. So first you describe, if we're gonna be using the liquid crystal library for the LCD. First we describe our liquid crystal. We name it, I named it LCD. And the first two pin are the enable pin and the RS pin, the enable pin and the RS pin, and then the rest of the pin are the signal pins. So pin 4, 5, 3, 2 are all signal pins. So the trigger pin, I'm gonna put it's pin 9, and the echo pin, it's pin 10. And in the duration is the time it takes for our ultrasonic sensor to detect a signal back. So, and the distance is pretty much now, after doing all the calculation, it gives us this distance that we're gonna read on the LCD. So in the setup, I'm gonna describe the size of my LCD. It's a 16 by 2. Pin mode, trig pin output. The trig pin is an output because it sends the ultrasonic signals. And the echo pin is an input because that's what receives or read the signal back, the ultrasonic signal coming back after reflecting on the object. We begin the serial monitor just for if we want to read anything or debug stuff. In the loop, so first digital write trig pin low. So we put the trig pin low. We just make sure it's low for 2 seconds, and then this trig pin high, and then we put it high. So first you make sure it's low for 2 seconds, and then you put it high for 10 seconds, which gonna send 8 high ultrasonic bursts. So those ultrasonic bursts basically is gonna fire every two milliseconds for 10 every 2 milliseconds for 10 milliseconds. And So the digital now, after sending the ultrasonic burst by putting the trig pin high, we put the trig pin low. Basically, here we're creating a cycle. So it's gonna cycle like high, low, high, low, high, low, high, low. And duration dot pulsing echo high. So now this pulsing function is the function that detects how long the echo pin was high for. So after sending the ultrasonic burst, we receive the signal back, and the signal received is gonna put this echo pin high. And depending on how long the echo pin is gonna be high, and depending on how long this echo pin is gonna be high, it's gonna give us the distance. So to calculate the distance, we're gonna use the duration, basically how long the echo pin was high for. We're gonna use the duration and we'll multiply by 0.034. So basically this is the speed of sound in millisecond by in centimeter by millisecond. So its sound is usually measured in meter per second, but we convert this in centimeter per millisecond, which gives us 0.034. And you divide the whole thing by 2 because we have to account for the signal going in and then traveling the same distance back as well. And we print this distance on the serial monitor, which is really not necessary because we're gonna use an LCD to read it. And then we set the cursor for the LCD. We delay for 10 milliseconds and we print our distance on the LCD. So this is pretty much it for the code. Very simple, nothing too complicated. And I'm gonna plug the Arduino, upload the code, and see how it works.
So I plugged in my Arduino and I uploaded the code. As you can see, everything is working perfectly. Now we're gonna test it and see if it actually works, right? Because if it doesn't work, then all the work is just wasted. But so let's see if it works. So I 3D printed this little box a while ago to put some of my screws and whatever small stuff I didn't want to lose. So I 3D printed this. I'm gonna try using this and see if we can actually get some sort of somewhat accurate measurement with this ultrasonic sensor. So I'm gonna start by putting it here pretty close. As you can see, when it's close, we have a pretty good reading. So it's reading 3. You can also see on the ruler, it's exactly a 3. And I like to keep the decimal points just because it gives a sense of accuracy, but I know it's not very accurate. The decimal, you can just ignore the decimal at this point. But I just like to keep it because it looks cool. And yeah, so at 3, we have a pretty good reading. We're gonna bump it up at 6. And you can see at 6, we're reading 6.26, which is still pretty good. But that can already tell you that the further back you go, the less accurate the reading is. So we're gonna go 2 centimeter back at 8, and you can see that at 8 it's actually reading 9. At 8 it's reading 9, but if you move it, it goes back to 8. But you can see that it's reading 8, and the decimal point is very fidgety. So you can see that it's less accurate as you go back. The further back you go, it's less accurate. So we're gonna go even further back at 12, and now it's reading 12.56. And we're gonna go even further back at 18, and it's reading 18.81. 18 point, well, we can't really rely on the decimal, but it's reading 18, but it's really not that accurate as you go back, but for a simple ultrasonic sensor, this is enough. That's all we need, and it's working perfectly. And thank you very much for watching, guys. Let me know if you tried, let me know if it goes, and if you have any questions, just leave it in the comments. All right, thank you, guys.